All right, hello everyone, and welcome to our keep doing that. Our Super Stellar Friday. So we are going to be hearing from educator here, Dave McDonald, as well as State Representative Ellen Reed. And they are going to be talking about the eclipses that are coming to New Hampshire this year and next year. All right, take it away.
Take it away. All right, so I have Ellen to join me. And so I'm Dave McDonald, and I'm a senior educator here. I work now part-time on weekends. My full-time job is I teach STEM, astronomy, and computer stuff at Belmont High School up the road at 106 in Belmont, New Hampshire. And I'm a director on the New Hampshire Astronomical Society, and also have my fingers in a number of other pies. So I'm delighted to be here to share with you. And with me is Ellen Reed, New Hampshire State Representative from the Seacoast area, and I'll let her share a little bit about herself.
Thank you. So I am a state representative. That's one of the people that helps make the laws for New Hampshire. There's 400 of us in the state. I represent Newmarket and Newfields, which is out in the Seacoast area, close to Durham and not terribly far from Portsmouth. And I am a fellow member of the New Hampshire Astronomical Society, as well as a fellow member of the Solar Eclipse Task Force.
Yes, I didn't mention that.
You didn't mention it, but I mentioned it for you.
Thank you.
And
we're a good tag team.
my personal background, I got my bachelor's degree in molecular biology, but I was always interested in astronomy. My mother studied astronomy, and I grew up looking at her textbooks. And I took astronomy classes when I was in college. Then I kind of went into politics and into advocacy, and just in the last 4 or 5 years kind of returned to my science and math roots. And part of that was joining the Astronomical Society. And ever since then, I've been involved with the eclipse stuff. So
Yes. So round of applause. Welcome, Ellen.
they didn't give you an applause.
Oh, I don't need applause. Okay. All right. Well, thank you. We'll
Sit down.
be chatting in
Okay.
just a moment.
Okay.
Run along, sit down now.
All right.
Kidding. We're really good friends. Okay, so the eclipses are coming to a state near you. Guess what state that is? New Hampshire, right? And so we introduced ourselves here, and this is all about the sun, the moon, and you. And this slide is going to show up multiple times with multiple avenues to get there and away from there. So this is the path of the annular solar eclipse, which is coming right up. Can you believe it? A week from tomorrow. There's an eclipse in New Hampshire a week from tomorrow on Saturday. We'll talk a little more about that. It's an annular eclipse, which goes from Oregon down through, like it crosses like right in the 4 corners and then down into Texas. And then the majority of our chat will be about the April 8th total solar eclipse, which bingo hits our target area here in New Hampshire and other New England states as well. So first, another commercial talk. Speaking of the moon, you must know that 2 weeks from tomorrow is International Observe the Moon Night. And this is kind of cool because if you can imagine billions, dare I say, out of the 8 billion, there must be 2 billion. Billions of people looking at the same moon in the same 24-hour period. It's just kind of cool. And so at Bryant Field in Belmont, New Hampshire, which is off of Route 106, I think it's officially 1024 Laconia Road, but it's right there on 106, almost to the lights in Belmont. And we're going to have telescopes there. So it's International Observe the Moon Night. So we'll be looking at the moon for sure, but Jupiter will be featured, Saturn will be featured, and other things are available depending on how many telescopes we have, and what's going on. So we invite you to come to International Observe the Moon Night. We are an official NASA site. So if you Google International Observe the Moon Night event locations, we will pop up. So an eclipse is an astronomical event that occurs when an astronomical object temporarily obscured by the shadow of another body. So the sun is temporarily obscured by the moon. And we have, in that case, a solar eclipse of one sort or another. So speaking about the sun, moon, and you, back to that crossing point, this is an amazing place right here because it is so rare. I mean, we're talking thousands of years where one place has two eclipses, full eclipses. It's an annular eclipse, but it covers the sun, but just not all the way, and we'll explain why later. And then the total, right there, right near San Antonio, Texas. And I happen to be the vice president of the New Hampshire Total Solar Eclipse Task Force. And my buddy, Rick Yeames, is the president of the New Hampshire Total Solar Eclipse Task Force. And guess where he was last week? Near. He's standing on the spot. Now, how do we know that that's the spot? Thanks to my pre-calculus class back in 2019, I think it was. Yeah, May 14th, 2019, at 3:01 p.m., I sent to Rick the coordinates down to 6 decimal places of where that spot is. And I said then, it's in the woods. It's 211 feet westish from a class 6 road. Not clear if it's private property or not. I'll send pictures later, which I did. And my students had a lot of fun and excitement figuring it out. And so right here, oops, right here, he went there. He found the spot.
That's a very Rick picture.
It is. And if you know Rick, you would know that is a Rick picture. And that's awesome. And he's going to be somewhere on the path of annularity in Utah, I think, on that day. So he won't be in New Hampshire, which is fine because for that eclipse, this is the path of, let me just skip back for a sec. This is like, you're going to see the full annular eclipse here, but we're over here. So we will see this as a partial eclipse, about 20-ish% coverage. Okay, so 3 types of solar eclipses. We have the total solar eclipse where totally the sun is covered. The annular eclipse, which is coming up next Saturday, where the moon doesn't quite cover the whole sun. And then we have a partial eclipse, which is what we will experience on Saturday, next Saturday. So a couple things. It's the reason why the moon and the sun get to cover each other, whether it's a lunar eclipse or solar eclipse. Well, the sun is 400 times larger than the moon. But it's also 400 times further away. So 400 times larger at 400 times the distance, you know, kind of evens out. So they appear to be about the same size in the sky, but the orbit of the moon around Earth is elliptical, right? It's not a circle. So there are times when the moon is further away, called apogee, and there are times when the moon is closer to Earth, called perigee, and that determines the size of the moon and how much of the sun will get covered. These are important numbers. These are today's numbers. These numbers don't work tomorrow. 8 days to the partial solar eclipse, week from tomorrow. 185 days to the total solar eclipse up in Coos County, New Hampshire. And 20,283 days to the next total solar eclipse that'll happen in New Hampshire. So
What year is that?
it is 2079. 2079. So mark your calendars. Some of you don't need to bother. So what is an eclipse? So here's some things. So we already said it's an event where one celestial object casts a shadow on another. So the sun is over there. We don't know where the daughter went. So the sun's over there. Earth is in the middle. And we have the moon in two different places. So we don't have like two moons, but we have two stories to tell. So this story is the sun is over there, Earth is here, the moon is here, and Earth is so much larger than the moon that all of the moon gets to be in the shadow of Earth during a total lunar eclipse. All of Earth is in Earth, all of the moon is in Earth's shadow. A solar eclipse is when the moon is between Earth and the sun, which is over there, and the moon blocks the sun, but the shadow cast by the moon just appears over a very small area. As a matter of fact, for the upcoming April 8th eclipse, this path of totalities only 128 miles wide. So you've got to be within this 128 mile wide highway to see totality at all. And you know, don't you? The diameter of Earth is 8,000 miles. The circumference of Earth is about 25,000 miles. And we only get a 128 mile path to be in totality. So it's very rare to have a total solar eclipse in any one place. They happen a couple times a year somewhere, but for it to happen in any particular place, it's rare. Total lunar eclipse, I explained, has to be a full moon, get a total lunar eclipse, and then your total solar eclipse, the moon shadow falls on Earth. And that's during a phase we call the new moon, when the moon, sun, Earth are lined up in the phase called the new moon. Lunar eclipses happen during the lunar phase called a full moon. And the nice thing, again, as I already said, a lunar eclipse, everybody on Earth gets to see it. On a solar eclipse, about 1/10 of 1% of Earth's population can see it. A lunar eclipse is when the moon moves into Earth's shadow, and you see this red, sometimes it's called the red blood moon. It doesn't go dark, it doesn't go away, because what's happening and why it's red is what's around Earth, hopefully everywhere, hopefully for a long time. What's around Earth? Yes. Air, atmosphere. And what do we enjoy sometimes in the summertime when the sun sets? You see sometimes a nice red sky, red clouds, red sun, big red sun as it sets. And sometimes it happens in the morning. And you know the saying, red sun at night, sailors delight, red sun in the morning, sailors take warning. But in any case, we have sunrises and sunsets that are red. And what's happening here on the full moon is all the sunrises and all the sunsets happening on Earth are being reflected off of the moon. And that's what makes the blood red moon. So why don't we have a lunar eclipse at every full moon and a solar eclipse at every new moon? Because the moon's orbit is about 5 degrees tilted, 5.1, 5 degrees tilted from the orbit of Earth around the sun. We've got this tilt, which means the moon doesn't always line up directly, moon, Earth, sun. So we have to get on a node. You know what I mean? So there's the ascending node when the moon in its orbit is going up and crosses the plane of the ecliptic, which is the pathway of the sun. Or on the way down, what we call the descending node, when the path of the moon crosses the ecliptic plane. And those are the only times that we can get a lunar or a solar eclipse. That always doesn't line up during, I mean, it happens all the time, every month, but it doesn't always happen during a new moon or a full moon. This has to happen during a full moon or a new moon to get the eclipse. So here is the 3 types of solar eclipses again. The total eclipse, where we have the moon fully covering, blocking the sun, so that we get a target area of blackness. There's what's called the penumbra, where it's a partial eclipse, but again, that 128, it's different for each eclipse. Like each one may go from 110 to 160, depends on the eclipse and the exact geometry. But this one is like 128-mile wide path on average. So here you have the total solar eclipse. An annular eclipse, again, is when you can see the moon is further away from Earth, so its size appears smaller and it can't quite totally cover the sun. So we get this annulus. So annular doesn't mean like yearly, and it's an annulus, it's a ring. So that's why it's called annular eclipse, because of the annulus, the ring. And then the partial eclipse is when the target area is, the full target is like off Earth, like over here. So we just get the partialness hitting Earth. We would have to be in a spaceship away from Earth to experience that totality. So this gives you an idea at perigee, which I told you is when the moon is closest to Earth. We have a distance of 221,699 miles away, and it appears to be this big. But then when it's at apogee, A, away, that's how I remember the two. A, away, A, apogee. When it's further away, we're at 250, we're over 250,000 miles away. 498 miles. So the moon appears smaller in the sky. So you kind of get the idea of why sometimes all of the sun is covered and why sometimes most, but not all of the sun is covered. I see a hand.
Is it true that the sun's apparent size also slightly changes through the year? I think it's closer in January and further in.
Good for you.
Yeah.
We just watched a slight little rabbit trail, which I'm really good at. Just today, in my astronomy class, we watched this video clip. Very cool video clip. Would you like to hear about it?
Yes.
I want to see it.
If we had time, I'm sure we could. Harvard University, graduation. These students have gone through elementary, middle school, high school, learning about the season. They're at Harvard University. This is their graduation day. They have caps and gowns on. And the person doing this project comes up to them with their VHS camera and says, "What causes the season?" And all of them say, well, when Earth is closer to the sun, it's summer. And when Earth is further from the sun, it's winter. But it's the other way around. as Ellen said, we're closest to the sun in January 4th. We're furthest away from the sun July 4th. Hope they enjoyed paying for that, Harvey. One of the most famous eclipses. Someone said, I wasn't sure if I should put it in quotes in there because this is my recollection of what was said. But in any case, someone said, massive objects can bend the path of light. Who would say such a thing?
Einstein.
Yes. And this is about the age at which he said that. This is like, I think 32 years old in this photo. You were used to seeing the old guy with the fuzzy, frizzy hair. But, you know, he didn't look that way all his life. I mean, he didn't marry twice. This is it. In 1913, he sent a letter to astronomer G.E. Hale of the Hale telescope. And he said to look for the bending of starlight during a solar eclipse. And this is in German. I can't read it, but I can read, you know, the date is there's a 13 there. And this is the picture of the sun. And there's a star here. And that's where the star is. But due to the gravitational attraction of the sun, because it's a massive object, it's going to appear as though the sun is here when it's really over there. The light is going to be bent this way, so it looks like the star is here when it's really here. And people are like, yeah, right. Well, that was in 1913 that Einstein predicted this. He says, look, the only thing we need is a total solar eclipse. Well, on May 29th, Einstein was your basic scientist. On May 30th, he was world famous because he was right. And the fact of massive objects bending the fabric of space-time was proven to be true in this letter. And he adjusted it, you know, he didn't wait until after the fact, but this, you probably can't see it, but it says 0.84 seconds of arc. It was actually 1.75 seconds of arc, which he amended this. I don't have a copy of that letter, but he amended it before it happened and said, you know, it's actually going to be 1.75. I was about twice off. And it was true. Go Einstein.
With an eclipse to thank for it.
And we have an eclipse to thank for that. So absolutely. So this is what we're going to see Saturday, something like this. We'll have telescopes here. We'll have telescopes up at Bryant Field also, but if you live around this area, I encourage you to come here, having a big party. I'll tell you about in a minute. So sunspots. So it's not just you're going to see the eclipse through safe solar viewing telescopes. We'll have eclipse glasses for sale, and probably you'll see some sunspots. So this is our party here, all day, 11:30 to 4 p.m. next Saturday. And the sweet spot is 1:24 p.m. is when, again, it's not going to be total. We're going to see about 20-ish% coverage, but that maximum 20% is going to be around 1:24 in the afternoon. But you know, you get to see it all day, and we won't be having a planetarium show at 1 or 2 o'clock. So as everybody can, not be, oh, should I go to a planetarium show? So we'll make it easy. Go look at the sun with your eclipse glasses and through the telescope. So now, let us shift to April 8th, 2024. Ready for this? This is what we're going to see Saturday. April 8th, you see that. If you're in the right place, which will tell you where that is. It's up in Coas County. I forget which way it is. I've got two pictures to show you, this one and the next one. My daughter took one with her camera. I took one with my camera. I don't remember which is which, without a solar filter. This is, when you get totality, you can take your eclipse glasses off for that 2 or 3 minutes. And you can take a picture with your camera, cell phone, and get that without a filter. So my daughter or I took that, and one of us took this. These aren't National Geographic photographs. We went down to Hopkinsville, Kentucky, August 21st, 2017. We were there on the center line. A church, I mean, there's all kinds of people in that whole area. There were signs on the road. Do not pull over for the eclipse. You know, there's all kinds of highway signs all over the place. Do not pull over for the eclipse. There's a total solar eclipse today. Keep your eyes on the road. And you know, safety things like that. But the church that we were at, founded online, was selling 20 by 20 foot boxes for $30 a night, which is a whole lot better than $300 a night at the local hotels that are fleecing the tourists. So we bought a square for $30 for one night, and they had breakfast. Well, they had donuts and coffee for free. This easily 300 people there. Donuts and coffee for free. They had a nice lunch buffet, hot dogs, hamburgers, beans, chicken for $10. It was wonderful. And we experienced this. And I want to tell you something. If these lights were on a dimmer, I would illustrate. But you got to picture this. It takes 2 to 3 hours for the full eclipse to happen. From the beginning, first contact, to the end, fourth contact. It's 2 to 3 hours, depending on exactly where you are and which eclipse you're watching. It slowly dims. Slowly. So that if you didn't know a total solar eclipse was happening, you probably wouldn't know there was a total solar eclipse happening until dim, 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 a little dimmer. The lights go out. The lights go out. The bugs, the birds, the animals are clearly confused. Stars come out. I took this one, or my daughter did, one of us did, and it doesn't look like you can quite see the stars. But anyway, there are stars and planets in both of these images. Can't quite see one there either. But take my word for it, there's stars there. And planets, Mercury, Venus, that are close to the sun. And then it moves away. And now we have the solar filter on. This is through a small telescope. And this is my family. Me, my daughter, and my wife. We bought Kentucky Eclipse t-shirts, of course. This is the telescope that took those pictures from. Video camera with solar filter gel on it, Mylar actually. And so we had like 4 cameras, 1 telescope, and a partridge in a pear tree, and the monitor. It was 111 degrees, went down to 79. 111 to 79 degrees when it was total. And then the temperature came up, it was getting later in the afternoon, so it got up to maybe 108 or something later. Can you imagine this one? On April 8th, 2024, can you imagine it's in your own backyard in New Hampshire? Can you imagine missing it? Can you imagine not going for a little drive? See, it's the sun, moon, and you. What are you gonna do on April 4th, 2024 in this area here? You live down here, you wanna go up there. Trust me, it's a Monday. You're not gonna get up and back on Monday. I'll talk a little more about that. So now we enter, oh, I left something in the car. Maybe I'll get it later. But in 2019, a group of us, that's me and Sally Jensen and Rick, Cody York is a student of mine. He's now a senior at Berkeley Music School in Boston, but he was a senior in my astronomy class and my pre-calculus class. And in any case, we met and started making plans in 2019 about lodging, making reservations back in 2019. And people said, no way, who's coming all the way up here? When I was at Hopkinsville, Kentucky, when the eclipse was over, we drove 5 miles west, interstate highway, 4 lanes going north. So 8 lanes, right? 4 coming south, 4 going up, 4 lanes going north. Nobody's moving, parking lot. Fortunately, I saw, like, I got on the ramp and I saw that. I saw, oh, I did a U-turn on the ramp. Fortunately, nobody behind me. I might not have cared. And then we drove 20 miles east to another interstate, 4 lanes going north, parking lot. Nobody's moving. Don't worry, we have 3. We're up good to go. You see what I'm saying? Nobody's going up and back. So that annular eclipse happens in Coos Bay County, Oregon, the annular, and the total happens in Coos County, New Hampshire, and we made a partnership. And these are proclamations that I have one in my car that I just forgot to bring in. So maybe during the break, I'll bring it in so you can look at it if you want to. But anyway, so 60 people from New Hampshire, students, representatives, adults, kids, 30 people from New Hampshire signed it. We made 60 copies. I signed my name 60 times. We sent all 60 of these proclamations to the seat of Coos Bay County. They had 30 people of their people sign it, and they sent 30 of them back to us. So they have 30, we have 30, making this pact of sisterhood, brotherhood of the eclipses. Very cool. So, on August 11th, 2021, Governor Sununu signs a bill making April 8th, 2024 official New Hampshire total solar eclipse day. And so with that, I want to turn her over to Ellen, our state representative, Ellen Reed, to share a little bit about the proclamation. And we're going to be talking about, where did it go?
Oh, no.
There it is. No, there it is.
No.
Let's talk education.
Let's
talk legislation.
I was about to thank you for going past the picture that I'm in there. So in 2020, and legislative season begins in like January. In early 2020, I put in a bill, and it was really a proclamation, a governor proclamation declaring April 8th, total solar eclipse day. I really wanted to shut down the schools to give students an ample opportunity. The moment of totality is actually around 3:30 p.m., which is not a convenient time. Teachers won't be able to actually educate the kids and be with the kids and make sure that they view it in a safe way. A lot of times parents won't be with their kids, and it's just a really bad time. Plus the traffic situation that Dave brought up, I really kind of wanted to make it a true holiday. couldn't get support for that. So we went with a proclamation. Proclamation is about, I don't know if you can operate the thing. It's about 4 or 5 sentences long. Would you like me to read it? Okay. Now, this is what I wrote. It's kind of flowery, okay? Because remember, it's the governor's proclamation. Since before recorded history, human action, imagination, and passion have been inspired and guided by the celestial bodies, none more important than our sun, the source of all life on earth, and our moon, our constant reminder of beauty, change, and hope in times of darkness. On April 8th, 2024, the sun, the moon, and we here on earth will perfectly align in a total solar eclipse, an exceptional and providential occurrence over the ages, reminding our species once again of just how small we are, how insignificant our differences are, how vast and powerful the universe that sustains us is, and how we are all indeed intimately and irrevocably connected to one another. New Hampshire will have the unique good fortune of being in the path of totality of this magnificent phenomenon in perfect alignment with our sun and moon. Moreover, New Hampshire, in the same spirit that we welcome all to participate in our unique political landscape, shall once again open its arms so that all people from around the country and the globe can be here at the moment to witness and be humbled by the awe-inspiring sight of the heavenly bodies moving in their spheres. The governor shall proclaim April 8th, 2024 as total solar eclipse day in New Hampshire and shall urge all citizens of the state to commemorate the day with appropriate educational activities. So there you go. That's the whole thing. So I don't know if you can continue. So at the time I did this, and by the way, it was 2020, and I said I put it in January 2020. It didn't, all government stopped a few months later. It didn't pass that year. It got tabled, like 700 other bills got tabled. But it did get signed by the governor in 2021. Magnetic thing hit the microphone. But recently I kind of revisited the idea of making it a true state holiday so that some parents could be home and kids could be home, and you could really try to actually observe it and have educational guidance. And I found out that it gets out, it's like the totality is at 3:30. It's just a terrible time, and the traffic is going to be awful. You guys familiar with like Memorial Day weekend and the Massachusetts people coming? Yeah, like imagine that whole weekend on a Monday at 3:30. Okay, it's going to be really bad. So I thought, well, maybe I'll put in a bill this year and I can maybe get it fast tracked to get a holiday. And so I went to the Commissioner of Education and proposed the idea. And I was astonished. I thought he was going to kind of kick me out of his office, but he's super excited about it and wants to work on the bill with us. So right now it's kind of unofficial, but we have a very strong indication from the Commissioner of Education that he will actually not only help us write the bill, but come and testify for it, which basically assures its passage. So he wants the Astronomical Society and the Total Solar Eclipse Task Force to help with the curricula for that day. And the idea is it's going to be a learn at home day, not necessarily remote learning on the computer, but students would be sent home with the grade appropriate kind of homework assignment. And that could either be observing in person or not. But that's kind of the idea that we're going for. So that's the bill. I did have a question. Is it okay if I ask kind of a related, but not legislation related?
Yeah. Because I mentioned in my blurb that it would be audience participation.
Okay, well, I have a question for the audience. And the reason I have this question is because when we talk about shadows and the moon and everything, this is something that stumped me all the way, I think, through high school until I found out. Now, Dave just told you that a total solar eclipse. Well, let me back up. So you know how the full moon is a full moon, right? Big circle moon. The new moon, we call new moon, it looks like it's blacked out. You can still see like the moon, but it looks black, right? And then we have a crescent moon, sometimes called a fingernail moon, and a half moon, and a gibbous moon is kind of the opposite of the fingernail moon. So Dave just told you that a total solar eclipse or a solar eclipse of any kind is when we are in the shadow of the moon. So the moon's between us, it's the sun, the moon, and us, and we're in the shadow. And that a lunar eclipse is when the moon is in our shadow. So here's my question, because I got confused. What shadow causes the crescent moon and the gibbous moon and the half moon and the new moon? What shadow causes that? Yep. You had your hand up? Oh, you're stretching? Okay. Okay. It was a very interesting time to stretch. Does anybody know what shadow that is? That's what I thought. Yeah. It's the moon's shadow. It's the moon's shadow, the moon's own shadow. Just like if you were to shine a light on my face right now, and this side of my face would be dark, this would be light. That would be like a half moon. So that's something that actually confused me for a while as a student, and the difference between those phases of the moon and an actual lunar eclipse. Is there anything else you wanted me to cover? Because you just kind of like threw me out. I did the legislation thing.
Great.
Okay.
So,
Does anybody have a
maybe we could see if
question?
Anybody has any?
Yeah.
ideas About how we should handle education.
That's great.
that day.
Does anybody have any questions of me or any ideas for how we deal with the education and the solar eclipse? I saw your hand. So what I want to happen is, instead of class being held that day, for schools to kind of hold, like, you know, in their playgrounds or what have you, on their grounds, like an open community available, like observing session, so that the teachers can literally teach everyone, not just the students that show up, but the parents and everybody else. And have that as a recommendation that comes out of the Department of Education. That's been my suggestion. Is the Astronomical Society, have they already started planning stuff? I'm sure we will have things.
Most of the astronomical society people are going.
Traveling.
They travel. That's their nature. We'll have, I'm sure, something going on here. It's a Monday, but there'll be neat stuff going on here. There'll be about 96% coverage. And what I'm gonna say next, which I'm gonna ask you, Ellen.
Yeah.
the Question I asked you before. I'm not discouraging anybody from coming here. There'll be about 96-ish% coverage here. And that sounds like a lot. I mean, if I got a 96% on an exam, I'm good to go. But my question for Ellen is, suppose I get up to Bethlehem, Profile, Prophet Notch, and I'm getting up there, Kingdom Angus Highway, and I'm getting up to where it's 99% coverage. Is that good enough?
99%. No. Here's the thing with so that you'll still be partial at that point. And the whole thing about a total solar eclipse is it really, like he said, bam, it turns daylight into midnight. And 99% is not enough to have that light switch go off. At 99%, it will look dusky or like a very overcast day. It'll be interesting, and you can still see with your glasses, you'll still be able to see the moon obscure the sun almost completely, but you can't take your glasses off, and you won't have that moment, that really awe-inspiring moment of somebody just turned out all the lights in the world. And you really kind of want it, if you can at all, travel for it. And if COAS is kind of not your thing, you know, that path of totality goes through the entire region, New York State, Vermont, Maine, Canada. So there are different places that you can travel, and even further down in the rest of the country. Yeah. Yeah, Niagara Falls directly, which it feels like that's probably going to be really, really crowded that day. So, because a lot of people are like, let's combine Niagara Falls with the eclipse. Mm.
Is there anything about having a spot on video or something that?
Oh, there will definitely be streaming. And I imagine actually news stations typically will cover it as well, but there'll definitely be live streaming on YouTube and social media. NASA does it, yes. So you can see it on TV. And if you can't travel, it's still really amazing to watch a partial through your glasses. Not only is it amazing to see, but you do get a really eerie effect even with a partial. Sometimes the animals kind of, go quiet and the shadows get weird. So it's not just overcast. Like some of the shadows will sometimes look kind of unreal. It'll just be a kind of a weird atmosphere. So it's still worth observing, even if you're at 96%. But if you can travel, it's worth traveling for the total solar eclipse and get in that path of totality. Yeah.
What's the last one?
The last one in New Hampshire,
35.
1935, he says. So it is effectively once in a lifetime for any one location. Like you said, there's a couple a year, and the more hardcore among astro people will travel the world to follow total solar eclipses. Eclipse chasers. That brave 111-degree heat. But yeah, for one location, it's pretty rare.
About the glasses and why we need to get them and when should we get them? Because I'm feeling that a lot of people.
Get 'em now.
You should get them as soon as possible. They're relatively inexpensive, and actually, again, this is all unofficial as of yet, but in my meeting with the Commissioner of Education, he said that they definitely have in the budget enough money to order glasses for every student in New Hampshire. So that's about 65,000 glasses. So hopefully if you have kids in school, hopefully they'll be coming home with some. The Astronomical Society, Rick in particular, probably still has a few hundred. I know I have like 100 at home myself. So
Selling here too, Paul?
but
As in free?
So on October 14th,
on October 14th,
we will have the glasses available for free. So you can come get them during the time of the eclipse. So that'll be from around 12:30 to 2:30. We will be handing those out that day.
did everybody hear that? Okay.
Just an FYI, you can use other things like if you're into welding, people welding companies.
Yeah.
Number 14 welding left.
Number 14, Dave says, number 14 welding glass will do the job. But it is important to wear significant protection because you're staring at the sun will damage your eyes, even if you're not aware of it in the moment. I personally can't imagine staring anything too bright is, I wouldn't say painful, but just impossible to look at. So I don't understand people who can look straight at the sun, but apparently some people can. Any other questions or ideas or comments? Yeah.
I have kind of a factoid to just with the how precisely these can be dated after the fact or before the fact. So the earliest event in history that can be dated down to precision, the very day it happened, was a battle in 585 BC in present-day Turkey, and the battle stopped, and the two sides signed a truce or whatever, but they know exactly when it happened because it was stopped by an eclipse. So.
That's awesome. And that kind of goes back to that language that I wrote, right? Like, I know for me, and it's great that we have the International Observe the Moon Night, because for me, I think you get into astronomy because you have an initial moment of either you're seeing the rings around Saturn through a telescope or the spot on Jupiter, or just looking at the moon through binoculars is really amazing. It looks like you can touch the texture, right? It's so there, much more there than you're used to the moon being. And it's that inspiration that kind of lets you experience the feeling of, oh, all of the stuff we're worried about here is really not that big a deal. There's bigger stuff than us in the universe. So apparently a total solar eclipse was enough to get a war to stop, or at least a battle, maybe not the whole war. Oh, it did. So they actually stopped the war. They signed the truce and everything. So a whole war stopped because, and yet another thing we can attribute to a total solar eclipse. I love it. The ending of war,
Battle of the eclipse.
the battle of the eclipse. I love that. All right.
I heard that somebody who was captured by some tribe down in the Amazon was about to be burned at the stake and eaten, but he knew there was an eclipse coming, and he did this. The sun was covered, and they're like, oh, and they're like, bring it back, bring it back. So he went back, and instead of eating it, it was like.
It sounds like a movie. I'm pretty sure that was a movie.
So it's still fun. Still fun. Thanks. So this is kind of a, a black and white progression of the moon being covered. You see this diamond ring effect here, totality, a reverse diamond ring effect. And so it uncovers again 2 to 3 hours for the whole thing to go by. And so I'm going to skip ahead because, like I told you, I got like 90 minutes altogether. You can talk about sarocycles, and 3 sarocycles get you back to the twin eclipse, which is about almost 55 years, so 54 years and 34 days. There's a reason for that number that we can talk about another time. This is like an example of Saros 145 that's happening. Saros 136. These are like eclipses that have a common shape, a common geometry to them that can go from 1220 years to 1550 years. So you don't need to read that. And this is Saros 139. Again, you can see the similarities, 1973, 2027, 2081. They're very similar, but they're off by a third of the day. They're off by 8 hours. So our 2024 eclipse is going to be Saros 139. And the peak duration along the path will be 7 minutes and 29 seconds. But that won't be until the eclipse of 2186. But that's like the max time that you can have. And then I have all these things to read. You want to come up and see them later. But what I do want to show you is this next video, which is about 5 minutes. So this is the path. Be there. Don't be left in the dark. Actually, that's where you want to be. It's in the dark. That's why I thought that myself. All right, so this is going to be a video. We'll turn the lights off so you can see it and experience the sound. This is a guy who went to, it wasn't where I was, but it was along the path of what? It's pretty dark.
That's just like a total solar.
But your eyes will adjust. Like I can see you guys in the back. And so anyway, this guy was at totality for the 2017 eclipse. And I thought he did a marvelous job with the equipment he had documenting it, over 2 to 3 hour eclipse, and whittling it down to like 5+ minutes. So I hope that it works and you enjoyed it.
It's August 21st, 2017, the day of the total solar eclipse. I'm in Madras, Oregon. The skies are clear. This is my sky tracker. It's meant to move the camera with the sky, so it sort of compensates for the Earth's rotation. That should help me keep the sun in shot as the eclipse is taking place. We have first contact. This is C1. You can just see the moon entering on the top right side. We are 17 minutes out from totality, and I think the light is starting to change. I think it is getting noticeably dimmer. There's a bit of like a cold wind coming in from this side. Can you guys feel it? It's getting kind of cool. and it's getting darker. I'm really excited. Now that the sun is about 90% covered, I'm seeing much sharper shadows. Normally shadows, they're a little bit fuzzy because the light from the sun is coming from a whole bunch of locations, but now because it's coming from basically one little sliver of the sun, the shadows are all getting very, very sharp.
See how bright it is.
Oh my God. Oh my God. Ah. This is insane right now. Oh, this is just unbelievable. What? What is happening? This is absolutely insane. I feel like it's hard to breathe. Oh. Oh my God. This is so totally creepy. Oh my goodness. This feels so weird. Oh my goodness. There's like sunset, sunrise, every direction. People are going nuts. This I did not expect. I don't know what I expected, but oh my God. This just looks so wrong. You can see these prominences, the solar corona coming out the top left and right at the bottom. I can see Venus directly above me. You can see the stars. Oh, what? What is this? What? I just don't even know. We are inside totality. I am kind of speechless. It is just unreal right now. Isn't it? It's totally nuts. What? Oh, the hole in the sky. But it's so dark. 360. Our excitement that the sun is back. I'm gonna pop the solar filter back on. Yeah. I just want to say a huge thank you to my Patreon supporters. You made it possible for me to buy a flight here and for the equipment that kept my camera tracking with the sun and the solar filters on the front. And yeah, basically everything I needed to get here and see this total solar eclipse. So thank you so much for supporting me. You make it possible to keep doing the things I love doing and making these videos.
What do you think? Here comes the light. I missed that. You don't want to miss that.
I think it's interesting when you could see the sun coming back and how much sunlight it looked like, but when you put the filter on, you can see it was just barely the tiniest little sliver that was causing that much light.
The eclipse still happens, but we don't get to see it. We will experience still the dimming and the darkness, but you just, you're not gonna see the sign of corona. These are like signs, this is for the August 21st. And, so that concludes our presentation. So, other questions for either of us?
Are you aware of places like the church you said did that special thing down there? Are you aware of places, in New Hampshire that are doing anything?
Along those lines, I would, give a call, to some churches and ask, and you may put an idea in their brain, is there, I mean, there's, you know what I'm saying? I mean, there's money to be made, I mean, if you have some, you know, a big lawn yourself, you know,
Well, I would,
but the porta potties are almost gone.
I would add the caveat that yours was in the summer in Kentucky. This is
Yeah.
in April in Coas.
Yeah,
So maybe camping isn't for everyone at that point.
there'll probably be still snow on the ground, probably, yeah. Yeah,
I think another concern is for the part of New Hampshire that gets totality is so heavily forest. I don't know what the angle is going to be at totality of being in the sky, but you're gonna want to kind of try to get a little bit of meadows that you have up that way, or, you know, I know there's a fire tower.
you wanna be looking somewhat up south to southwest, with a relatively good, again, we're in April, we're just past the equinox. So the sun's not gonna be super high, but it's not, you know, super low either. But that's, you know, a good point, you wanna be able to have a, you know, a good angle. It's about 3:30 in the afternoon. So we are in daylight savings time at that point. What we're gonna do is we're gonna take a 10-minute break, so you can use the restroom, get a drink of water. And then we're going to gather, if you want to, in the theater, and we have a planetarium show, about 24 minutes, called Totality. That is, you know, full 40-foot dome show about the eclipses coming up, and then we'll go to tonight's sky and show you exactly what the eclipse will look like from Concord, and what the eclipse will look like up in Coas County, and see if you decide, I think I'm gonna drive. Last call for any questions, comments, thoughts? So about 10-minute break, and then we'll meet down at the theater. Thank you for coming.